Why does mesh tape keep failing on the hairline cracks above your door frames and window headers, even when you follow every YouTube tutorial and mud it perfectly? The answer is not that you did it wrong. The answer is that mesh tape was never designed for hairline cracks in the first place. It was designed for drywall seams and butt joints, and using it on a 1/4 millimeter stress crack above a door frame is the wrong tool for the wrong problem. There is a better method. It takes about 15 minutes per crack. It costs under $20 in materials, and the repair actually lasts because it flexes with the building instead of fighting it. 28 years in the drywall and paint trade taught me the hard way that mesh tape on a hairline crack is a problem waiting to come back on your next hot summer or cold winter. 28 years in the trade, working out of a paint van across Ohio, Pennsylvania, and Texas, and I have re-repaired more mesh-taped hairline cracks than I want to count. The pattern is always the same. A homeowner watches a mudding tutorial, tapes a 24-inch stretch of wall above a door frame, sands it down, paints it, and 6 months later the crack telegraphs right back through the paint in a slightly different location because the tape moved with the drywall, but the door frame kept slamming. The fiber-reinforced compound method I am going to walk you through today is what commercial paint contractors and drywall repair specialists have quietly been using for the last decade instead of tape. And stick around to the end, because there is a 5-second lighting test using nothing but your phone flashlight that tells you within one look whether your repair passed or is going to fail before you even pick up a paintbrush. The thing the traditional drywall trade has trained American homeowners to forget is that a hairline crack is a movement problem, not a hole. A drywall seam is a hole. Mesh tape and joint compound fill holes beautifully. But a hairline crack above a door frame is a place where the building is moving, expanding and contracting with the seasons, shaking with every slammed door, settling with every load on the floor above. Tape does not stop movement. Tape moves with the underlying drywall and telegraphs the movement right through the finish coat. The fix is not more tape. The fix is a fiber-reinforced compound that has internal structural fibers built into the material itself, so the repair becomes a flexible bridge across the crack instead of a rigid patch over it. Once you understand that hairline cracks are a movement problem, you stop taping them and you start filling them with the right compound. Your walls stop coming back and your paint stays put. The principle is straight material science. Mesh tape is a self-adhesive fiberglass mesh, roughly 2 inches wide, designed to reinforce standard joint compound across a drywall seam that is 1/8 inch to a 1/4 inch wide. The tape sits between 2 full sheets of drywall and gives the joint compound something to grip while the compound builds up in 3 coats to a smooth, level surface. That is what mesh tape is for. That is what it does well. What it does not do well is bridge a hairline crack in an already painted wall surface, where the substrate underneath is intact drywall, and the crack itself is a hair-thin split in the paint, and the top layer of the joint compound. When you mesh tape a hairline crack, 3 problems happen at once. First, the tape adds a raised bump to your wall that has to be feathered out over a 12 to 16-inch spread. Otherwise, you get a visible ridge every time light hits the wall at a shallow angle. Feathering that spread takes multiple coats and hours of skilled sanding. Second, the standard joint compound you skim over the tape has 0 flexibility. It is a rigid gypsum-based material designed to harden like plaster. When the door frame flexes and the wall moves during seasonal expansion, the rigid compound cracks along the same line as the original hairline. The mesh underneath does not stop this, because the mesh is only holding the compound together. It is not holding the wall together. Third, sanding a mesh tape patch generates fine gypsum dust that coats everything in a 15-foot radius, which for a hairline crack that was maybe 8 inches long, is a completely disproportionate mess for the size of the problem. Every homeowner over the age of 40 has stood in a hallway with an LED bulb in the ceiling light overhead, looked up at the door frame trim, and seen that hairline crack running diagonally from the top corner of the door frame up toward the ceiling. You painted it out 6 months ago. It came back. You mudded it and taped it a year before that. It came back a little wider. Every time the door slams, every time the AC kicks on and cools the drywall by 15 degrees, every time the humidity drops in November, that crack widens by a hair and then closes again in spring. That is the movement I am talking about. The crack is telling you the building is alive underneath the paint. Tape does not silence it. The right compound does. The fix is a fiber-reinforced spackling compound, sold under a few different brand names at any home center or paint supply store. The three main options are 3M High-Strength Small Hole Repair, DAP Drydex Wall Repair Patch Kit, and Red Devil One-Time Lightweight Spackling. All three contain fiberglass or acrylic microfibers suspended in an acrylic latex base, which means the cured material is flexible instead of rigid, and it flexes with the wall movement instead of cracking against it. Cost per tub runs about $6 to $12, depending on the brand and the container size. One 5.5-ounce tub, which is roughly the size of a standard yogurt cup, repairs somewhere between 15 and 20 typical hairline cracks in a residential home, so materials cost per crack lands at under $1, and the tub lasts you 2 to 3 years of touch-up work. The compound looks like a pink or off-white paste in the tub when you open it. Some brands, like DAP Drydex, are pink when wet and dry to a white color as a visual cue that the material has cured, which is a homeowner-friendly feature the paint pros do not need, but the DIY market appreciates. The acrylic latex base is what gives the material its flexibility. The fibers are what give it internal structural integrity, so the flexible cured patch cannot separate at the crack line under future stress. Together, the two ingredients replace mesh tape and rigid joint compound with one material that does the job of both, without the raised bump and without the massive sanding mess. If you compare this to trying to caulk the crack with a cheap acrylic latex caulk from the hardware store, the difference is that caulk stays rubbery forever, and paint does not adhere to it cleanly, so you get a shiny stripe every time light hits the repair. The fiber-reinforced compound cures to a paintable, sandable finish that accepts the wall paint the same way the surrounding drywall does. Caulk is for baseboards and window trim gaps. Fiber-reinforced compound is for hairline wall cracks. The procedure starts before you open the tub. Take a stiff putty knife, the kind with a rigid steel blade about 1.5 inches wide, and drag the sharp corner of the blade along the crack line to score it open slightly. Not deep, not a trench, just enough to remove loose paint flakes, old joint compound crumbs, and any chalky debris sitting in the crack from previous failed repairs. The score line should be maybe 1/16 of an inch deep, which is about the thickness of 2 credit cards stacked together, and it opens the crack just enough for the new compound to physically key into the intact drywall paper underneath. Sweep the loose material out of the crack with a 2-inch chip brush, the kind that costs $2 at any home center, or vacuum it out with the crevice attachment on a shop vac. A clean crack is the entire foundation of the repair. Compound will not bond to dust. Now the step that separates the paint pros from the DIY repair videos on YouTube. Apply a bonding primer or deep penetrating drywall sealer directly into the scored crack before you touch the compound. Zinsser Guards is the pro standard. Kil's Original Oil-Based is the harder hitting option for previously oil-painted walls, and Bullseye 123 is the water-based general-purpose alternative. Any of the three works. A small artist brush, the kind that costs $1 at a craft store, is perfect for applying the primer inside the scored line. Let it dry for the manufacturer-specified time, usually 30 minutes to an hour, before you fill the crack. Skipping this step is the single most common reason hairline crack repairs fail within a year. The exposed drywall paper and cut edges inside the scored line are extremely porous. If you fill an unprimed crack with fiber-reinforced compound, the drywall wicks the water out of the compound within the first 2 minutes, causing the material to shrink premature to full cure, which weakens the bond and eventually reopens the crack under the first thermal cycle. With the primer dry, load your putty knife with a small amount of compound, about the size of a quarter, and apply it to the crack at a 45-degree angle across the crack line, not along it. Pushing the compound crosswise forces the material down into the full depth of the scored channel. Wiping it along the crack just spreads material across the surface, without filling the void underneath, which is a mistake nearly every homeowner makes on their first attempt. Once the compound is packed into the crack, tilt the knife to about a 60-degree angle, and drag it straight down along the crack with light, steady pressure to strip away any excess material from the wall surface. Leave the compound inside the crack. Keep the surrounding wall as clean as possible. Less excess material on the wall means less sanding later, which means less dust and a faster overall repair. If you are getting something out of this so far, subscribe. There are more of these breakdowns coming. The cure time depends on temperature, humidity, and crack depth. In a Texas summer with the AC set at 76 degrees and the humidity around 45%, a hairline crack repair cures in about 45 minutes to an hour. In a Pennsylvania basement in February, with the humidity down at 25%, the same crack cures in about 30 minutes because the dry air pulls moisture out of the compound faster. In a Gulf Coast Louisiana summer, with 85% humidity, cure times can stretch to 2 or 3 hours because the ambient moisture in the air slows evaporation. The pink to white color change on dry decks is a good visual cue for cure completion. The other brands you have to judge by touch. If the surface feels firm and no material transfers to your finger when you press lightly, the material is cured enough to sand. Sanding is where amateurs create the visible hump that gives away every DIY drywall repair. Use a fine grit, 220 grit, or 320 grit on a small sanding block about the size of a bar of soap. Do not use an electric orbital sander for hairline crack repairs. The orbital removes too much material too fast and generates aggressive dust plumes that require plastic sheeting to contain. A hand sanding block gives you the control to feather the edges of the repair patch out to nothing over roughly a 2-inch radius from the crack line, which is what makes the finished repair invisible under raking light. Sand with light circular motions, feathering the outer edges more than the center of the patch, and stop the moment the surface transitions smoothly from patch to surrounding wall without any tactile ridge under your fingertips. I will be honest, the first time I tried this method somewhere around year 14 of my career on a hallway repair in a Pennsylvania row house, I skipped the primer step because I thought a fiber-reinforced compound would grip fine on its own. It did grip, for about 8 months. Then the winter humidity dropped, the door frame contracted, and the crack telegraphed right back through the paint at the same location. Had to grind it out, prime it properly, refill, sand, and repaint. Cost me a Saturday and a lesson I did not want to learn. The bonding primer is not optional. Anybody who tells you otherwise has not repeated the same repair on the same wall enough times to see the failure pattern. The reason primer matters so much is chemical. Fiber-reinforced compounds are water-based acrylic latex materials. The water in the compound is what carries the acrylic binder and the fibers into position inside the crack, and the water is also what evaporates during cure to lock the material into place. Bare drywall paper and gypsum core inside a scored crack are extremely absorbent, so absorbent that they will pull water out of the compound within 30 seconds of contact, before the acrylic binder has time to flow into the crack profile and grip the substrate. A bonding primer seals that porosity and equalizes the water balance during cure, so the compound cures at its intended rate rather than a rushed rate. The result is a stronger cured patch with better bond strength and less shrinkage. Skip the primer and you skip the chemistry. And the chemistry is what makes the flexibility work. 3 real objections worth handling head-on. First, why not just use paintable caulk? Because paintable acrylic latex caulk stays rubbery for the life of the tube. Paint applied over caulk sits on top of the rubber layer and does not bond into the wall, so you get a visible glossy stripe every time light hits the repair, and the caulk shrinks over the first 6 months as it cures, opening a hairline gap at each edge of the repair. Caulk belongs at baseboards, window trim gaps, and door casings, where the elastic property helps the material accommodate wood movement. Caulk on a drywall hairline crack is a temporary fix that looks unprofessional and fails on paint adhesion. Second, why not use the traditional mesh tape plus joint compound method the drywall trade taught for 50 years? Because it works fine on wide seams and butt joints, and it does not work on hairline stress cracks. The rigid gypsum compound cracks along the movement line, no matter how much mesh you put underneath. The mesh was never the load-bearing material, it was just a compound reinforcer. On a hairline crack, you need flexibility, not compound reinforcement. Third, when do you actually still need to tape and mud instead of using the fiber-reinforced compound method? Cracks wider than a 1/4 inch, drywall corners that have completely separated from the framing behind them, and any crack running through a corner bead where the metal or paper reinforcement is bent or damaged. Those are structural drywall problems, not hairline movement cracks, and they need traditional tape and mud repair to restore the compound depth and profile the wall lost. The rule I use in the field is this: under a 1/16 of an inch wide, always fiber reinforced compound, no tape. Between a 1/16 and a 1/4 inch, judgment call based on cause and location, but usually still fiber reinforced compound with a lightly wider scored channel. Over a 1/4 inch, go back to mesh tape and standard joint compound. This is not a rule the drywall trade will tell you, because most drywall guys who do not paint do not repair hairline stress cracks for a living. They build new walls or repair damaged sections. The fiber-reinforced approach came out of the paint contractor trade, not the drywall trade. My wife watched me score a hairline crack above the master bedroom door frame one Saturday morning with a putty knife and a brush and a tiny tub of pink Drydex, and she asked me why I was fussing over a crack she could barely see. I said because in 6 months she was going to see it and complain about it if I did not fix it right. She said in 6 months she would not remember it existed. 28 years of explaining wall repair to her over coffee, and she still has the same line every Saturday I unload a tub of compound from the truck. She runs the thermostat at 68 degrees in summer, and I run it at 76. So technically the temperature swing in the house is her fault every time a hairline crack shows up in a drywall corner. The engineering works either direction. Cracks behave differently in different climates, and the fix strategy has to account for that. In Texas Hill Country and Central Texas, where the summer humidity swings from 25% in July to 65% in September, hairline cracks tend to open in dry months and partially close in humid months. The fiber-reinforced compound handles this cycle beautifully because the acrylic base has enough elasticity to move with the small dimensional changes without failing. In Pennsylvania row houses and Ohio Victorian homes, where the winter heating dries the air to 15% relative humidity for 4 straight months, hairline cracks open dramatically in December through February and close back partially in June. The pattern is more severe and the compound has to work harder, but the same product does the job. A buddy of mine who runs a small paint and drywall shop in Phoenix tells me his cracks behave differently again, because the desert humidity stays low year-round, and the diurnal temperature swing is the driver, not the seasonal humidity swing. His route, his conditions, but the fiber-reinforced compound is what he specifies to his customers, because it handles the mechanical stress from thermal cycling, as well as it handles the moisture cycling in humid climates. A homeowner on the Home Repair Forum out of Charlotte, North Carolina, posted his before and after data last spring after using the fiber-reinforced compound method on 12 hairline cracks throughout his 1960s ranch house. 12 cracks repaired over one weekend using 1 tub of 3M high-strength small-hole repair, about $18 in total material spend, including a small can of Zinsser Guards primer and a $4 chip brush. 2 seasons later, he reported 0 cracks reopening. His numbers, not mine, and one house is not a controlled study, but it matches what I see in my own service log on residential paint jobs across Central Texas for the last decade. The method holds up in the field. Run the math on what a typical American homeowner has spent chasing hairline cracks over 15 or 20 years of homeownership. A paint contractor charges roughly $175 to $300 to come out and repair a series of hairline cracks in a hallway, feathering, sanding, priming, and repainting a 2 or 3 foot section around each one. If you have called a pro twice over 20 years to repair the same set of cracks in the same hallway, that is $350 to $600 in labor for something a $12 tub of fiber-reinforced compound, a $6 primer, and a $2 chip brush would have fixed permanently in one weekend. Times the same math across 2 or 3 doorways in a typical home, and the accumulated spend runs into 4 figures across the life of the house. Nobody scammed you. Paint contractors get paid to feather and sand and match texture, and the fiber-reinforced compound method skips half their billable hours, so nobody sitting on a paint van truck volunteers the shortcut. The information moves through the trade at the paint counter, not through the customer estimate. What I almost did not include is the 5-second lighting test that tells you before you even paint whether your compound repair passed or is going to fail. Same kind of pre-paint inspection I use on every professional job I turn in. The test is free, takes no tools beyond your phone, and gives you a pass or fail answer that saves you an entire second round of repairs. Wait until dark or dim the room lights. Turn on your phone flashlight, the one built into the LED on the back of the camera, and hold the phone flat against the wall about 4 inches away from the repair. Point the light along the wall surface, not directly at the repair, so the beam skims across the wall at a shallow angle of about 10 to 15 degrees off parallel. This is called raking light, and it is the same technique professional painters use to inspect drywall finish work before signing off on a job. Any ridge, any hump, any depression, any unfilled section of the crack shows up as a bright shadow or highlight the moment the raking light hits it. A properly repaired hairline crack under raking light looks like a slightly matte stripe with no dimensional change from the surrounding wall. Concrete examples of what raking light reveals. A repair that shows a bright ridge along the crack line means you left too much compound on the surface, and you need to sand more before painting. A repair that shows a dark trough or shadow line means the compound shrank into the crack during cure, and you need to apply a second thin coat before sanding and painting. A repair that looks completely flat and matte under raking light means you nailed it. Paint it. In Pittsburgh, Pennsylvania, on interior LED-lit hallways, the raking light test catches roughly 80% of amateur repair mistakes before the paint goes on. In Texas Hill Country homes with large, uncovered windows and strong afternoon sidelight, the wall does not need a flashlight because the natural raking light from the west windows already exposes every imperfection during golden hour. Match your inspection lighting to the lighting the wall will actually live under during daily use. That is how professional painters check their own work before charging you for it. One last piece worth covering before you paint the finished repair. After sanding, and before the final wall color goes on, apply a small spot prime coat over the repaired patch using the same bonding primer you used inside the scored crack. A 1-inch chip brush is fine for the application, and the goal is to seal the raw sanded compound surface so the finished paint absorbs into the wall the same way it absorbs into the surrounding original paint. Skip the spot prime, and you get a visible dull halo around the repair where the finished paint soaked into the porous compound differently than into the sealed wall around it. This is called a flashing halo in the paint trade, and it is the single most common giveaway that a homeowner did their own drywall repair. A 5-minute spot prime step eliminates it completely. Wait for the spot prime to dry per the label, usually about 30 minutes. Then roll the wall color across the repair using the same nap roller cover you used on the original wall. A 1/4-inch nap for smooth walls, a 3/8-inch nap for lightly textured walls, and a 1/2-inch nap for orange peel texture. The nap size matters because it produces the stipple pattern that blends the repaired section into the surrounding wall texture. Match the nap and the paint blends invisibly. Change the nap and the repair shows up as a smoother or rougher patch under raking light. That is the whole method. A stiff putty knife, a chip brush, a tub of fiber-reinforced spackling compound, a small can of bonding primer, a fine grit sanding block, and a phone flashlight. Under $25 in total materials, for enough supply to fix every hairline crack in a typical American home for the next 3 years. The drywall trade did not hide the technique from you. The traditional trade just never had a reason to teach it, because the traditional trade builds new walls and repairs big holes, not hairline stress cracks above door frames. That work moved to the paint contractor trade over the last 2 decades, and the paint pros figured out that mesh tape was the wrong tool for the job, somewhere around 2010, when the fiber-reinforced compounds became widely available at retail. The information is out there. It just does not travel through the drywall trade channels anymore, and it does not show up in your neighborhood paint contractor's sales estimate because the shortcut cuts his billable hours. Whether you use the method is a question of one weekend and $25 at the paint supply counter.